Hey, welcome. We'll get started here pretty soon. Going to be doing some Cisco networking. We're going to be looking at OSPF and how to enable a dynamic routing protocol between these routers right here. All right, let's go. So, yesterday we started to initialize OSPF on, I think it was router 2 right here. Let's go to PC 0. Let's get our pings going. Y'all share this with anybody that you think might benefit from a little bit of Ethernet, IP networking, particularly dynamic routing protocols like OSPF, which is exactly what we're working with today. All right. So here's PC 0, says it right there. Our default gateway is 10.10.10.254. That's the HSRP virtual router between these two right here. Okay, I think router 2 is currently active. We can look at that if in a minute if we need to. So let's ping this PC over here, PC 1, which is on the 10.10.11 subnet, as you can see right there. Okay. 10.10.11.10. And so currently, yes, we are active HSRP on router 2 because we can tell because our response that we are not able to route to PC number 1, the IP address of router 2 is coming back and telling us, hey, the destination is unreachable. All right. So this is what you get from a router usually when there's no routing capability. When it's missing routing information that it needs to deliver the packets. I think there might be another case where you get this, maybe even strangely, as I recall, sometimes in an access control list, if it's dropping traffic, you might get a message similar to this. But in our case, we're not using ACLs. We are using OSPF, and we're initializing it. So let's go over here to router 2, and let's look at what is going on. Just to confirm, show standby. Oh, enable. Thanks for the likes. Thanks for the joins. Welcome, everyone. Another day of networking fun. Okay. So, yeah, we are currently active. And so let's look at our routing table. Show IP routes. We do not have 10.10.11 in the routing table. We could have asked for it just like that, 10.10.11.0. Subnet not in table. All right. You can even use a mask, network mask. Okay, I was looking for something that some routers have. Another limitation of packet tracer. Sometimes you can put longer prefixes, an option there. But anyway, I'm going to move our ping down here because we want to see that in real time when it starts working. Okay, so we're not learning that route, and it's because we haven't fully initialized OSPF. Show IP OSPF interface. We can see that we are running OSPF on loopback 0, on gigabit 000, and on gigabit 001. Okay? So let's go back and look. Show run section router OSPF. Let's look at what we did yesterday. We enabled the process router OSPF 1. Again, the number 1 is just a locally significant process ID. And we put the most or the least specific of all filters to run OSPF on an interface. 0.0.0.0, 255, 255, 255. Did I say enough 255s? 255, 255, 255, 255. This means we're going to match on every IP address on every interface on this router, and we are going to enable OSPF, and we're going to start sending out OSPF hellos. All right, there we go. Hello due in 2 seconds. So you can see, show OSPF interface, pipe include. Can I include? No, you can't. Yeah, but we can ask for a particular interface. Let's just look at this one. 5, 4, 3, 2, no, not 3, 1, 0, 9. So every 10 seconds, a hello is going out. See? Hello due in 0 seconds. Hello due in 1 second. So I redid that command over and over to show you that OSPF hellos are going out every 10 seconds. Oh, it even tells you that right there. Timer intervals configured. These are the default timers on an Ethernet interface. Hello every 10 seconds. The dead timer is 40. Wait timer is 40. And there's a retransmit of 5. So we can see the hellos are going out. Okay, so let's do this same thing on the other routers. Show run, section, router, OSPF. I'm going to copy this, and I'm just simply going to paste it into the other routers. We have router 3 we need to enable OSPF on, and router 4. Then they will establish neighborship, and they will exchange what are known as link state advertisements, and then they will build a they'll build a topology tree using an algorithm, and then they populate the routing table. Okay. Thanks for the likes. Thanks for the joins. Y'all forward this live to anybody you think might be able to benefit from a little bit of CCNA level. You know what? I hesitate to say CCNA. I don't even know how much the CCNA gets into OSPF. But, you know, it's good to know some of this. It might even prepare you for CCNP. Okay, so show IP OSPF neighbor. That's what I wanted. Neighbor. So we have no neighbors. So let's put this in a notepad. And let's get ready to copy this to router 3 and router 4. Okay. And I'm not even going to exit out. I'll just, okay, here's router 3. Let's paste that in there. There we go. All right. Show IP. Oh, look at that. Messages. Quick OSPF messages. So, OSPF adjacency change. All right. Process ID 1. Neighbor 10.255.2 on gigabit 000 from loading to full. So it was loading its link state database, and full, it established a full adjacency. And then on another interface, G001, went from loading to full. All right. So let's look at this real quick. Show IP OSPF neighbor. We have an OSPF neighbor, but we have the same neighbor twice. And we're going to talk about this in a moment. We're just going to leave it the way it is for now. So we established neighborship. Let's go back over to router 2, and we should likewise see similar messages, and we do. 10.10.12.3. Oh, look what I did. Look what I forgot to do. I forgot to put the loopback interface on router 3 so that it advertises itself to router 2 using the loopback as its router ID. So let me get back in here, and I need to pull up the file from yesterday that shows our IP addressing scheme. When y'all are working with networks, you need to keep track of your IP addresses so that, well, just because you better keep track of your IP addresses because you don't want to reuse addresses more than once and create duplicate assignments. And you have to be able to have good documentation so that you know what your available address space is and what has already been used. Okay, so this is the router loopbacks, router 2, 3, and 4. And here's the configuration. Oh, and here's the subnets that we used for the LAN segments and for the transit subnet between the routers. Okay, so this is what we did for router 2 yesterday. Let's do the same thing for router 3. All right, let's put that in there for router 3. And I'm going to look real quick on router 2's perspective, show IP OSPF neighbor. I want to know if this router ID changes right away. This is going to be interesting. Also, on router 3, if you just type show IP OSPF, it tells you the ID is 10.10.12.3. I want to know if that's going to change also. So let's paste this in here. All right. We see that the loopback came up. Let's see if OSPF changed. It did not. Still has that router ID from before. Let's go over to router 2, and those have not changed. So you know what I'm going to do? I'm going to clear OSPF. Clear IP OSPF. This will clear the process. Clear IP OSPF process. Hit enter. Reset all OSPF processes. If you're not familiar with the way Cisco runs their inline questioning like this, whenever it asks a question, the answer that is already populated in the brackets is what will be the default answer if you just hit the enter key. All right? So if I hit enter, it will not reset anything. Okay, so what did we do there? We did absolutely nothing. I just hit enter to demonstrate show IP OSPF neighbors, details. Neighbor is up for 3 minutes. Neighbor is up for 3 minutes. Okay, so nothing happened. Let's try that again. Clear IP OSPF process. This time, if you want to change from the default answer in brackets, you need to type something different. So let's type yes. There we go. Oh, there we go. Look, check it out. So OSPF adjacency change. And we went from full to down, full to down. Okay, then we went back from loading to full, loading to full. So let's check this out. Let's look at the process. Interesting. Routing process with ID 10.10.12.3. What does this other one show? Show IP OSPF. This one has the loopback. Show run section router OSPF. You know what? And I'm also going to suggest that you define the router ID in the process. Let's start with router 2. OSPF 1, router ID. Let's put that in there. Okay, so that's hard-coded in there. We'll save that. There we go. Now we got the router ID command in there. Let's do this to router 3 and see if we can get better results before we have to just remove the process altogether and start all over again. So show run section router OSPF. You know what? I'm going to look at my loopback real quick. Do show IP interface brief. The loopback is there and it is up. Okay, so let's paste this in. Let's change that to 3. Interesting. Look at this command. Router ID 10.10.255.3. Reload or use clear IP OSPF process for this to take effect. All right. Well, we did that a minute ago, but now that we've hard-coded it, show IP OSPF. Okay, it's still 10.10.12.3. Let's see if clearing the process now will act differently since we've hard-coded it. Okay, the neighbors go down. the neighbors come back up. Yes, there they are. Show, and there we go. Very good. So it worked in the way that we're trying to go about doing this. It worked by coding it into the OSPF process. You know what? I'm going to take a moment and look at some of these comments. Thanks for the follows, folks. And thanks for the roses. Okay. Yes, you can modify the timers. Absolutely. I think to speed OSPF convergence along, sometimes that is done. Okay, so let's keep moving. All right, so we have OSPF here, show IP OSPF neighbors. Let's go to router 4. Let's get our loopback ready. And let's just put the show run section router OSPF. Let's put this same configuration into router 4. All right, so here we go. Watching these pings down here because I'm pretty confident that these pings are going to start flowing once we get router 4 working. Okay, this is router 4. Let's paste this in. Okay, the loopback came up. We are watching for OSPF neighbor states. Show IP OSPF neighbor. Oh, look at that. From loading to full, but I had previously typed the command just a second before these messages, and look what you saw. Xstart, DR, and BDR. We can talk about designated router and backup designated router elections later, and what causes one to be the DR and the other to be the BDR. There we go. Look at those pings. They're coming through slowly. There we go. Here they come. All right, so it's working. And show IP OSPF neighbors shows that we have 2 neighbors. One to router 3 and the other one to router 2. Let's look in router 4's routing table. Show IP routes. And look at this. So now not only do we have connected and local routes, we've talked at length about those the last few days. We won't talk about those again, but now we have the letter O listed 1, 2, and 3 times. The letter O stands for OSPF. All right? So if you only want to see your OSPF routes, show IP route OSPF. All right? I don't know if y'all can hear that noise outside my window. I think it's a weed eater. Somebody cutting grass. And there we go. So show IP routes OSPF. Router 4 has learned 3 OSPF routes. One of them has a equal cost path, so it's listed with 2 next hops. That being 10.10.10.0/24. All right. So let's look at this. Interestingly, hold on a second. That's pretty interesting. Check this out. When you type show IP routes, and I don't know if this is a limitation with Packet Tracer, when you show IP route, it shows you that the 10/8 network is variably subnetted, all right? Because there's listings of the 10/8 through here with various maskings, 2/24/32, okay? But the thing I want to point out is the OSPF routes are showing what the mask is. /24, OSPF, /32, OSPF /32. Check this out. When I type show IP routes OSPF, the masks are no longer there. Isn't that weird? I don't know if I've seen that before. It no longer shows the masks. You can't tell by looking at this output what the actual masks are for those listed subnets or loopback addresses. So that's interesting. All right, so back to this. 10.10.10.0/24 is the network over here. And so it's connected to router 2, it's connected to router 3, and it's being sent to router 4 with an equal cost. So router 4 is learning about it via 2 paths. Okay? This first number is the administrative distance. That is the method by which it was learned. OSPF is an administrative distance of 110. And then this is the metric, 1. Pretty sure that's the outgoing metric of each interface on the way to the destination subnet. So whatever the metric is of router 4's interface going out, then the router interfaces here going out. The cumulative result of that is what this aggregate metric is listed as. So show IP OSPF interface. Look at that. We're going out G000. Let's copy that. Let's paste that here. I forgot the G. If we look at this, look what we see. Cost of 1. Okay? This is router 4. So router 4 going out G000. Let's move that. There it is, G000. Going out towards 10.10.10.0. Then if you go to, say for instance, router 2, and you do the same thing, show IP routes, and you look for the interface that goes to 10.10.10.0, copy that, show IP OSPF interface, paste that, cost of 1. So cost of 1 on router 2 to get to 10.10.10.0, and then cost of 1 on router 4 to get to 10.10, cost of router 4 in that same interface to get to 10.10.10.0. When you add up 1 plus 1, you get 2. There you go. All right. So the least cost path the least cost path is what is going to be listed as the next hop in transit to that destination subnet. All right? All right. So let me show you that. Yeah, actually, I want to circle back on something. I want to circle back on the fact that router 2 and router 3 are both neighboring with each other twice. Remember that? Remember, show IP OSPF neighbor. So now if you look at router 3, you have router 2 in here twice, but then you have router 4. Now that makes sense to be neighboring with router 4 and router 2, both on G001, because that is the backbone connection here. All right? The core, kind of like we could call that the core of the network. But we're neighboring OSPF across the LAN, and that's often not desirable. So what you'll want to do is, if you don't want to neighbor on a certain LAN segment, you're going to need to make this interface passive, G000 and G000. Also, if there's no other routers out here that you want to neighbor with, and you don't want PCs to be seeing your OSPF hellos, you will also want to go passive on that subnet. So the way to do that is show run section router OSPF. You go here. Let's copy that. paste it. Passive interface. Oh wait, I think you just typed the interface. G000. There we go. Soon as you put that passive statement in there, you will lose neighborship with that other router that with router 2 that we had formed a neighborship on that interface. Goes from full to down. Okay? Interface was detached. All right, let's do the same thing. Show IP OSPF neighbor. It's gone. Let's do the same thing on router 2. We'll just copy that command. Go over here to router 2. Excuse me. Router 2. And we're all good now. Show IP OSPF interface. Now, when we look at G001, we will see that it is in fact passive. Oh wait, oh excuse me, that was show IP OSPF neighbor G000. Excuse me, I stand corrected. Interface G000 is listed as a passive interface. And check this out, no hellos. So you have effectively turned off your hellos on that interface. And now we have a functional network, and PC0 can ping PC1. So this is good. We can trace route. There we go. 10, 10, 11, 10. And there we go. We see that we go 3 router hops. We go across router 2, then we go across router 4, then we get to PC1. All right. Let me look at some of these comments here. Show IP route OSPF. We'll show subnet mask. Okay. All right. Well, that's really all I got for today. And we have OSPF running and all is well. So that's pretty cool. Probably going to see you all tomorrow around the same time. Yeah, U.S. citizen 886. I do teach a couple courses for a training provider, but I'm thinking about maybe doing some on my own. And so yeah, you know, that might be something that I have in the future. Maybe add mentoring to it or coaching, assistance with certain types of technologies, or maybe even assistance with certification, you know, and just tailor the training to fit whatever the need is. But yeah, I might put together like a network fundamentals course or a routing course or a switching course. We'll see. Well, all right. Hey, it was fun. Y'all have a good rest of the day. Thank you.